Welcome to a review of both isotopes and chemical bonds. Now to review, the electron has a negative charge, the proton has a positive charge, the neutron has no charge, and the proton and the neutron make up what we call the nucleus of the atom. Please note there is no nuclear membrane. Now the magnitude of the positive charge equals the magnitude of the negative charge. So what that means is that protons have a +1 charge, electrons have a -1 charge, and if we add those together, that's an overall charge of 0 because all atoms are neutral. So the number of protons equals the number of electrons in an atom because it has a neutral charge. Now, the mass of a proton and the mass of the neutron are roughly the same thing, and we say that the mass of both of those is equal to 1 atomic mass unit, and the mass of the electron is basically 0 atomic mass units. So the entire mass is found in this nucleus of the atom. If you recall, the nucleus is extremely dense and it counts for almost all of the atom's mass. I mean, there's some mass in the electrons, but we do get to ignore those. If you recall, isotopes are exactly the same atom. By definition, they have the same number of protons, but they have different masses because they have different numbers of neutrons. So here's the hydrogen 1 isotope. It has 1 proton, 1 electron, and no neutrons. This is the hydrogen 2 isotope. It has 1 proton, 1 neutron, 1 electron. So its mass is 2. If you recall, all right, let's see, this top number right here is the mass, and the bottom number is the number of protons. Here in the hydrogen 3 isotope, the 3 is the mass, the 1 is the number of protons. So for hydrogen, it's always 1. It doesn't change. Isotopes will always be given the very similar, very generic form AZX, where A is the atomic mass and Z is the atomic number, the number of protons. To review bonding, there's 2 main types of bonds. There's ionic bonding, which are made up of cations and anions, and cations are always positive, anions are always negative. And then we have covalent bonds, and covalent bonds are either going to be polar or non-polar. And remember, an ionic bond isn't really a bond if you think about it, because some people say bonds are when electrons are shared. And in ionic bonds, the electrons are not shared. What happens is in an ionic bond, you have an electrostatic attraction that holds those two together. They're super, super strongly held together. In an ionic bond, one of the atoms will lose an electron. That electron goes to the other atom, making it an anion. So the sodium in this case ends up with a positive charge, the fluorine ends up with a negative charge, and those two together are drawn together with an electrostatic attraction. In a covalent bond, the electrons are shared. And if you recall, 2 electrons are shared per bond. So when the Lewis structures are pulled together, you can see that the hydrogen and oxygen share electrons. 2 electrons in 1 bond. In a polar covalent bond, all polar covalent bonds have a dipole. This is how we draw a dipole. And a dipole just means that there's uneven sharing. So the fluorine has a partial negative charge. It's drawing all of the electrons to it in the cloud. And fluorine's one of those great big hogs. Remember, fluorine, oxygen, nitrogen, NOF. Those are the 3 big electron hogs. And then this side of the molecule, the hydrogen side, has what we call a partial positive charge. So this is a polar covalent bond. Some things you need to remember about the periodic table: where you would find the metals. Those are all the ones in blue, the metalloids in pink, and the nonmetals in green. Don't forget, the ones in the middle are called transition metals. You should take a moment and fill out your periodic table with the different names of the families. These are another, you should remember these, but if you don't, yeah, you gotta know them. Periods are defined as the rows on the periodic table. There's 7 different periods. If you have colored pencils at home, by all means, color in your periodic table. Up next, we will be doing a review of nomenclature.